Before we dive into the assertion, it is persuasive to sort out what molecule gas pedals are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets. Similarly, it is the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could duplicate the exact conditions of the first time on Earth. This machine was designed to unlock the mysteries of the universe. It may hold the key to everything. Clearly, Boeing does something different. CERN, established in 1954, is one of the world's most prominent research organizations, with 23 member states and countless researchers. It's a place for collaboration and innovation. CERN's central project is the LHC, yet it's only one part of a vast organization of gas pedals and tests. Envision an unsuitable course, not for vehicles or people, but for subatomic particles. In a trial of attitude and persistence, the LHC accelerates protons to nearly the speed of light, sending them on a collision course that reflects the energy of the universe right after the Big Bang. The impacts create temperatures typically much hotter than the center of the Sun. A large number of magnets direct the protons as they travel through complex cooling systems, which keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 locations around the gas pedal ring, connecting with the spots of 4 detectors: CMS, ALICE, ATLAS, and LHCb. Each LHCb serves a distinct purpose, investigating different parts of particle physics. They work together to form massive cameras, capturing images of these collisions. Scientists then sift through the wreckage in search of evidence of the elusive Higgs boson, also called the God particle, and other anomalies that could reveal clues about the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. But with every revelation comes a second question. With each new discovery, a new obstacle appears. The LHC is more than just a science facility. It is a demonstration of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. However, as we push the boundaries of what we know, we must also consider more profound and existential questions. What are the risks associated with questioning the unknown? Could our quest for knowledge inadvertently unleash powers we have no control over? In the hallowed halls of CERN, where the limits of human understanding are constantly pushed, a revelation has arisen, one that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a voice of expertise in the field of particle physics, has recently said something that captivated the world at large, and made many uncomfortable. Cox's words resound with terrifying clarity. The objective of CERN's LHC is the mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this goal, highlighting the incredible potential of the LHC for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a substantial portion of the universe. Imagine holding the power of creation in the palms of your hands, to summon the very essence of the universe. It's an enticing possibility, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a very real phenomenon inside the LHC. The temperatures, the pressures, the raw energy, it creates conditions resembling those at the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. Yet with such power comes responsibility, and the question looms. What will happen if something goes wrong? In fact, something did go wrong back in 1978. The Russian physicist Anatoly Bugorsky encountered a disaster that would forever alter his life's trajectory. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a malfunction caused him to inadvertently enter the direct path of a proton beam. The beam, with a force that defies belief, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was extraordinary. He saw a flash brighter than 1,000 suns but had no immediate pain. The beam's path left behind a trail of destruction, burning tissue and bone. Yet, he remained conscious and even walked to the center for treatment. The outcome was both disturbing and remarkable. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Surprisingly, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy. It serves as a reminder of the sheer power and potential risks of particle accelerators. A particle smasher like the LHC is not to be underestimated. The potential for catastrophic reactions, for the very fabric of existence to be altered, is not science fiction, but a real concern voiced by respected scientists. One of the most unsettling and fascinating concerns associated with LHC experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are massive vacuum cleaners, devourers of stars, mysterious entities lurking in the shadows of our universe. Such a phenomenon could, theoretically, be produced by the LHC. Even on a small scale, the idea is staggering to both the public and scientists alike. Could this black hole eventually grow out of control, swallowing the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked discussion, anxiety, and awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends. If the object is heavy enough, it could create a well so deep that anything nearby would be drawn into it. This is an analogy for what could happen at the LHC, in the area of quantum physics, where the rules of the universe are both strange and wondrous. There is a hypothesis that additional dimensions might be hidden within the context of our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This strange dance of particles has even attracted the attention of a number of highly respected scientists. The late Stephen Hawking, in particular, wrote in his book that the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy the Earth, but could potentially destroy the entire universe. The respected English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the. Yet, despite the reassurances and safety protocols, the LHC remains a symbol of both hope and dread, a gateway to answers long sought, and a doorway to consequences yet unknown. The deeper we delve into the quantum world, the more we realize how little we truly understand. Our instruments, our theories, and even our confidence are constantly being tested. What began as a scientific ambition to unlock the secrets of the universe has, in many ways, become a philosophical journey as well, forcing us to confront what it means to question existence itself. What is the price of knowledge? How far are we willing to go in our pursuit of truth? For some, the LHC represents the peak of human potential, an achievement that proves our species' ability to rise above the mundane and reach for the stars, or even beyond them. For others, it's a chilling reminder that progress is not always synonymous with wisdom, and that even the most brilliant minds can miscalculate. Despite the risks, the work continues. Teams of scientists from around the world collaborate at CERN, united by a shared vision, to unravel the origins of mass, to decipher the riddles of dark matter, to peer into dimensions beyond our comprehension. And each breakthrough brings us a step closer, not only to understanding the universe, but to understanding ourselves. Because in the end, the experiments conducted at the LHC are not just about particles or energy levels. They are about identity, purpose, and our place in the cosmos. Every collision inside that colossal ring echoes a single question. What are we doing here? And perhaps, one day, in the patterns of the debris, in the fleeting trails of vanishing particles, we will find an answer. But until then, we will keep searching, one particle at a time. He was concerned about the LHC's activities and emphasized that there are rigorous safety protocols in place, thorough reviews and procedures to ensure the LHC's operations are carried out with the highest level of focus on detail. Cox reassured the public that the energies involved are well within the natural limits of Earth's experiences, and that the chances of constructing a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and unstable that it would rapidly dissipate in an explosion of energy, a phenomenon predicted by Stephen Hawking, called Hawking radiation. It would be a brief period of cosmic wonder, just a glimpse into the void, and then gone. Some have taken the idea even further, speculating that the experiments conducted by the LHC may open a door to a different dimension or universe. While this notion is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of intrigue, fear, and even myth. What lies beyond our universe? Could we accidentally release forces or entities that we don't understand? The concept of even opening a door to hell has been fanned into a media sensation, stoking the embers of uncertainty. But how did this idea come about, and what does it mean in terms of scientific exploration? The concept of additional dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there may be more than the usual 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from our perception, but they could, in theory, be accessed or revealed under extreme circumstances. Picture the LHC as a giant key, opening doors that have been locked since the beginning of recorded history. Instances of protons colliding at energies never before achieved on Earth could, in principle, create ripples or waves that probe these hidden dimensions. If these dimensions exist, the LHC might indeed uncover them. However, before we get too excited, it is important to comprehend that despite the LHC's undeniable power, there is no definitive proof to suggest it will open a door to another universe, let alone hell itself. Nonetheless, the allure of the unknown, together with the occult nature of quantum physics, guarantees that these concepts will keep the public imagination captivated. So, ought we to be concerned about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of catastrophe worldwide. But the truth is that the scientists at CERN are extremely mindful of the potential dangers. They have taken every precaution to ensure that the experiments are secure and continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly remarkable. It's not just an exposition of human ingenuity, but also a window into the very heart of the universe. However, like any great leap forward in science, it comes with its share of risks, and we should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its true potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unparalleled. Yet, despite strict safety measures and specific simulations, the LHC still evokes a sense of mystery and fear in some. The sheer scale of the machine and the energy it produces is motivating, and each result begins a journey into uncharted scientific territory. While most scientists remain confident about the safety of LHC experiments, there are undeniable uncertainties. What if new, unexpected anomalies challenge our understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge, and of what we can control in the natural world. As particle collisions replicate conditions hidden since the Big Bang, the significance of these experiments prompts existential inquiries concerning the potential outcomes of altering the very fabric of the universe. Regardless, the LHC's accomplishments in particle physics have been momentous. It has led to the discovery of the Higgs boson, improved our comprehension of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Nonetheless, the quest for knowledge remains one of mankind's most ambitious endeavors. The journey of scientific discovery is rarely without risk, and the LHC's experiments are no exception. They delve into areas of physics where intuition no longer applies. For decades, physicists have sought to understand the fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force, each playing a vital role in the formation of matter. As the LHC continues to operate and expand its experiments, the questions it raises become increasingly profound. With each discovery, the need for ethical consideration grows. The potential to manipulate and understand the fundamental building blocks of matter has far-reaching implications, not just for science, but for society as a whole. If the LHC unlocks the secrets of the universe, how will this knowledge be used? Will it be used for peaceful purposes, or could it be exploited for destructive means? Furthermore, the LHC represents an unprecedented collaboration between nations and scientists. Its success relies on the cooperation of thousands of individuals, all working toward a common goal: to answer the most profound questions about existence. The work being done at CERN is not just about understanding the past. It's about paving the way for future generations to unlock even greater mysteries. Innovations in technology and computing, often a byproduct of these experiments, can lead to breakthroughs in fields beyond particle physics. Despite the risks, the pursuit of knowledge remains an intrinsic part of human nature. With each step forward, we continue to push the limits of what we know, striving to grasp a better understanding of the universe that never leaves us alone. Large or small, the potential repercussions could be profound and long-lasting. As we venture deeper into the subatomic realm, we may uncover not only the mechanics of the universe, but also the philosophical foundations of existence itself. Are we merely observers, or participants in the shaping of reality? Does our increasing control over the fundamental forces grant us a responsibility we have yet to fully understand? The LHC's work brings us closer to answering some of humanity's oldest questions. What is the universe made of? Why does anything exist at all? Are we alone, or is there more, hidden dimensions, parallel worlds, or unseen forms of matter, that will rewrite everything we thought we knew? And yet, with each answer comes more questions. As the collider continues to smash particles together at incomprehensible speeds, revealing fleeting traces of exotic phenomena, it also underscores the vastness of what we don't know. Each breakthrough is a reminder that the universe is far more complex, mysterious, and awe-inspiring than we could ever imagine. But that mystery is also the spark that drives innovation. From medical technologies born out of particle detection methods, to revolutionary advancements in computing, the byproducts of CERN's research have already transformed our world. And they will continue to do so, whether by improving daily life or by expanding the boundaries of human potential. Still, caution must walk hand in hand with curiosity. As we tear deeper into the cosmic fabric, we must ask not just what we are capable of discovering, but why we are searching, and how we will use what we find. The LHC stands not only as a symbol of scientific achievement but as a mirror reflecting both the brilliance and the burden of human intellect. It is the legacy of a species unwilling to stop asking questions, even when the answers are terrifying, even when they are divine. And so, we look to the depths of the universe, not out of fear, but out of hope. Hope that by understanding the smallest fragments of reality, we might better understand ourselves. And in that pursuit, we inch ever closer to the sublime.